Let me start with one of the most common interview questions. What exactly is Playwright and where does it fit in modern automation testing? Playwright is a modern end-to-end automation testing framework created by Microsoft to test web applications reliably across all major browsers. It is designed keeping modern web technologies in mind, such as single-page applications, dynamic DOM updates, and heavy JavaScript execution. Playwright allows testers to automate Chromium, Firefox, and WebKit using a single API, which ensures true cross-browser testing. In today's fast-paced CI/CD environments, Playwright fits perfectly because it is fast, stable, and developer-friendly. A follow-up question often asked is, why did Microsoft create Playwright when Selenium already exists? The main reason is reliability. Selenium has been around for many years, but it struggles with flaky tests due to synchronization issues, driver dependencies, and browser inconsistencies. Playwright was built to solve these problems from the ground up. It communicates directly with the browser using native protocols, eliminating the dependency on external drivers. This direct communication makes Playwright faster and far more reliable, especially for modern applications built with React, Angular, or Vue. Interviewers then dive deeper and ask, explain Playwright's architecture. Playwright runs tests using Node.js and controls browsers through a single Playwright server process. Each browser instance can create multiple isolated browser contexts. These contexts behave like independent user profiles, each with its own cookies, cache, and session storage. This architecture allows Playwright to run tests in parallel efficiently while maintaining complete isolation between test cases. A very common practical question is, how does Playwright handle waiting and synchronization? Playwright uses intelligent auto-waiting by default. Whenever you perform an action like clicking, typing, or selecting, Playwright automatically waits for the element to be present, visible, enabled, and stable. It also waits for navigation and network requests to complete when required. This built-in synchronization removes the need for most explicit waits, reducing flakiness and making test scripts cleaner and more readable. Interviewers may then ask, can you still use explicit waits in Playwright? Yes, Playwright allows explicit waits when needed. You can wait for elements, URLs, network responses, or specific conditions. For example, waiting for a particular API response or waiting until the page reaches a network idle state. This flexibility gives testers full control in complex scenarios while still benefiting from auto-waiting in normal cases. Another popular interview question is, what are locators in Playwright and why are they important? Locators in Playwright represent a smart and resilient way to find elements. Instead of resolving elements immediately, locators re-evaluate the DOM every time an action is performed. This ensures that even if the DOM changes dynamically, the locator still works correctly. Playwright supports locators based on roles, text, labels, test IDs, CSS selectors, and XPath. Best practice is to use role-based or test ID selectors because they align with accessibility standards and are more stable. You may also be asked, how does Playwright support accessibility testing? Playwright integrates well with accessibility standards by allowing role-based selectors that are aligned with ARIA roles. This means tests are closer to how real users interact with the application, including users who rely on screen readers. Using these selectors also improves test stability and maintainability. Another strong interview question is, how do you handle authentication in Playwright for large test suites? Playwright provides a feature to store authentication state. Once a user logs in, cookies and local storage can be saved into a file and reused across multiple tests. This avoids repeated login steps and significantly improves test execution speed. This approach is especially useful for applications using OTP SSO or multi-step authentication. Interviewers also ask, how does Playwright support parallel execution and scalability? Playwright's test runner supports parallel execution out of the box. Tests can run across multiple workers, browsers, and devices simultaneously. Parallelism is configurable through the Playwright configuration file. This makes Playwright highly scalable and suitable for enterprise-level automation, where test execution time is critical. A deeper question is, how does Playwright handle flaky tests compared to other tools? Playwright reduces flakiness through auto-weighting, smart locators, built-in retries, and detailed debugging tools. If a test fails, Playwright can automatically retry it based on configuration. It also provides screenshots, videos, and execution traces, which make debugging extremely efficient. Interviewers may ask, what debugging features does Playwright provide? Playwright offers powerful debugging capabilities such as headed mode, slow motion execution, trace viewer, screenshots, and video recording. The trace viewer is particularly useful because it shows every action, network request, and DOM snapshot during test execution. This makes root cause analysis much easier compared to traditional tools. Another important interview question is, can Playwright handle API testing and backend validation? Yes, Playwright include built-in support for API testing. Testers can send HTTP requests, validate responses, headers, and status codes, and even chain API and UI tests together. This allows for hybrid automation strategies where data is prepared using APIs and verified through the UI, resulting in faster and more reliable tests. Interviewers often ask, how do you manage test data in Playwright? Test data can be managed using fixtures, external JSON files, environment variables, or APIs. Playwright fixtures allow setting up and tearing down data before and after tests, ensuring clean and repeatable executions. This approach aligns well with CI/CD pipelines. A senior level question is, how does Playwright integrate with CI/CD pipelines? Playwright integrates seamlessly with CI/CD tools like GitHub Actions, GitLab CI, Jenkins, and Azure DevOps. It runs in headless mode by default, supports Docker containers, and generates detailed HTML reports. This makes it ideal for continuous testing in modern DevOps environments. Another interview favorite is, what is Playwright CodeGen and when should it be used? Playwright CodeGen records user actions in the browser and generates automation code in real time. It is helpful for learning, quick prototyping, and onboarding beginners. However, in real-world projects, the generated code should be refactored to follow framework and design standards. Interviewers may ask, how does Playwright compare to Cypress? Both are modern tools, but Playwright supports multiple browsers including WebKit, whereas Cypress is primarily Chromium-based. Playwright also supports multiple tabs, iframes, and parallel execution more effectively. These features make Playwright more suitable for complex enterprise applications. Another strong question is, how do you handle file uploads and downloads in Playwright? Playwright provides built-in APIs to handle file uploads and downloads without relying on OS-level dialogues. This makes automation more stable and platform independent. Finally, interviewers ask, why should Playwright be chosen for future automation projects? Playwright is fast, reliable, scalable, and designed for modern web applications. It reduces flaky tests, improves developer productivity, integrates well with CI/CD, and supports both UI and API testing. For teams looking to future-proof their automation strategy, Playwright is an excellent choice. To conclude, if you want to crack Playwright interviews, focus on architecture, auto-weighting, browser context, parallel execution, debugging tools, and CI/CD integration. When you explain these concepts clearly and confidently, interviewers see you as a strong, job-ready automation engineer.